everyone, I think we're going to get started. I'm Talene Josephson, one of the members of ACAN Circular Economy Group, and I'm thrilled to welcome so many people to the third of our 9-part Circular Economy event series. It's exciting to see so much interest in the subject. This is another record-breaking event with over 1,000 signups. During our last event, we had over 500 attendees, the majority of whom identified themselves as architects. We hope to increase engagement amongst other related professions during today's Stage 2 event to spark some cross-disciplinary discussions. We'll send out a poll between speakers to find out a bit more about our audience. So before we get started, some house rules. The meeting is being recorded, so to avoid any background noise, microphones will be kept muted. If you have any questions for our speakers, please type your name and your question in the chat box and we'll come to them. I'm going to start with a very quick introduction to ACAN. ACAN is a network of individuals within architecture and the built environment, taking action to address the twin crises of climate and ecological breakdown. We have 3 overarching aims: decarbonize now, ecological generation, and cultural transformation. Our growing network is formed around thematic groups, including circular economy, education, embodied carbon, existing buildings, carbon literacy, planning policy, professional standards, and where the wild things aren't. We're an energetic bunch who work together to create change through movement building, campaigning, political lobbying, direct action, public engagement, research, and knowledge sharing. If you'd like to join any of these groups, please join the WhatsApp and Telegram broadcast channels. We'll post them in the links in the chat now. ACAN's Circular Economy Group has been focusing on how circular economy principles can be applied to the UK construction industry specifically, identifying opportunities and examples, as well as the many barriers to implementing circularity in the UK context. The number of attendees here today suggests that there are many like us who are enthusiastic about the circular economy in theory, but are finding it difficult to implement in the construction projects we're working on. We found experts from across the industry to dig down to the details of how to incorporate circularity in a meaningful way at each RIBA stage, from 0 to 7, with a final event to develop a proposal for new stage 8, closing the circle with deconstruction and reuse. Tickets for the next few events are already available and selling fast, so do snap up a ticket if you'd like to join us. To understand the context, here's a quick reminder of stage 2 taken from the RIBA Plan of Works. Following the establishment of a project brief during stage 1 containing the project and sustainability outcomes and quality aspirations, stage 2 is the time at which an architectural concept is developed and approved by the client in line with the project brief. The architectural concept incorporates strategic engineering requirements and is aligned to the cost plan, project strategies, and outline specifications. Depending on the procurement route, this could also be the stage at which a contractor is appointed. There's also the option to submit an outline planning application. So on with today's event. Today, we're delighted to be joined by David Cheshire, Regional Sustainability Director at AECOM and author of Building Revolutions, a RIBA book that applies circular economy to the built environment and has written best practice industry guidance, including CIBSE's Sustainability Guide, amongst other publications. David is a chartered environmentalist with over 20 years of experience, acting as a sustainability champion on a range of construction projects. Our second speaker, Salma Zavari, is an architect at the Copenhagen firm Vandkunsten. She has worked on several building material reuse schemes built for the cities of Copenhagen and Roskilde, including a series of projects repurposing shipping containers for affordable housing for young families, students, artists, and asylum seekers. David and Salma will be discussing how circular economy principles can be established within the concept design stage, including sharing real-life examples. We'll aim to keep the session to within 50 minutes. We'll first hear from our 2 presenters, after which there'll be an opportunity for questions during the Q&A session. We'll have a poll in between the speakers. We also have an interactive Miro board to which everyone is invited to contribute and continue the discussion. Any unanswered questions from the chat will be posted there, and the speakers will have a chance to answer them after the event. This will form the basis for a resource we'll produce at the end of the series, so all contributions are very welcome. We'll post the link in the chat now. So on to our first speaker, David.
Thanks, Talene. I'll just share my slides. Hopefully that's all okay. Thank you very much for inviting me to talk today. This is a great thing to be talking about, and I think it's really exciting to see the number of people here and to be thinking about what we should be doing at these early design stages. So I want to talk a little bit about what I think we could be doing, and I'll start with a little bit about the principles and what a circular economy is applied to buildings, which I'm sure a lot of you know, but I'll just do a quick intro to that. So really, this is all really about what we have at the moment, which is the linear economy, where we are digging a whole load of stuff out of the ground. We're mining all over the planet, and this is mining for bauxite to make aluminium, and this is in the Amazon rainforest, which just seems wrong on so many levels to be doing that. And then the other end of the scale, equally wrong in many ways, seems to be that we're demolishing all these old buildings, and sometimes they're only 30 or 40 years old, and you think, crumbs, that is it's a huge amount of effort, resources, and sleepless nights and time and effort that goes into building these buildings and designing and building, and then we end up with nothing much to show for it apart from a heap of crushed concrete and that we can't even really use again. I mean, it's used for road bases or for piling mats and things, but it wouldn't become structural concrete again. So a lot of the time when we're talking about our great recycling, we actually quite often what I'd call downcycling to a lower grade resource. And even the metals are the same, that quite often the alloys are recycled into a lower grade alloy or the metal alloy than they were originally. So a lot of waste and a lot of resource use, and that's the sort of nature of the linear economy that we're in. Dig stuff out of the ground, use it for a while and throw it away. And I think that, so the whole premise of the circular economy is that we can start to close that loop and create a much more keep and retain the value of our resources and materials, and ideally in perpetuity. So applying to buildings, what I did is I put together a framework into a simple diagram, which I'll build up over a couple of slides. So the basic and the simplest thing is the hierarchy, which is talking about retaining, refitting, and refurbishing our existing buildings. And then if we're building new, then we are designing so that they enable the retention, refit, and refurbishment through adaptability and things, rather than them being knocked down so soon. And then the outer three layers there are talking about how we would the bits of the building, really, how we'd reclaim and reuse the bits, which we do very little of at the moment. We mostly, as I say, crush and shred everything down to and sort of put it back into sort of atoms rather than actually keeping the bits, and then remanufacture components. So things like building services would be a great thing to start remanufacturing rather than destroying. And then the outer layer there is about recycling and composting as our last resort. So for technical materials, so in the cycle that I'm sure you've seen, the Ellen MacArthur Foundation butterfly diagram, it's called, with the two circles, you have the biological materials such as woods and fabrics that would go from the biosphere into use and then be cascaded back gradually into the biosphere and to be composted or to be anaerobically digested. So there's no burning and there's no landfill in the circular economy, at least in theory. And then for recycling of the technical materials such as the metals and the plastics, the idea that would go from manufacture into use and then go back to the manufacturer again. And that's the bit that isn't happening a lot because people just don't know, and it's an open loop. The responsibility for those materials moves from manufacturer to the buyer, to the contractor, and then to ultimately to the owners of the building. And then there's yet another stage, which is the demolition, of course, which is where that message is lost, that maybe there's something we could be doing to reclaim those back again. So that's the sort of basic premise, and then I'll just cover a couple of the design principles. So I've put in overlaid that with some design principles, none of which are particularly new, these ideas, but they fit very well in this in the circular economy model. And I'll talk about those in a minute. And then on the outside, the circular economy business models. Again, I'll mention one of those. And then this lovely idea of waste as a resource, and this idea that actually we have created as designers, and just in our linear economy, we've created the concept of waste, which wasn't there before. I mean, as I understand it, dustbins were genuinely used for dust, and that was it originally. They weren't full of all our packaging and plastics and all the other stuff that we throw in them now. And actually, in nature, there is no such thing as waste. One system, any waste coming out of one system then becomes a nutrient for the other system, and the concept of waste could be eliminated if we as design, and when we're designing things, we think about the next life and the next life and the next life of the building or the component and the materials. So that's the basic idea. So just a quick run through some of those design principles and some examples. So it's a very useful model, which I'm sure you've seen, the Stuart Brand model, which was originally Frank Duffy. The idea that the building is hugely complex and thousands of components in it, and actually they have very different lifespans, and they need to be they need to be made independent. So, for example, the structure might have a 100-year life, but the interiors, particularly if it's a commercial building, a retail premises, for example, or office, would be, stripped out for every lease period, which might be 2 years or even less. And then so the carpets or the ceiling tiles might be thrown out, and carpet tiles particularly go to landfill, and carpet goes to landfill generally. Whereas the structure, with a 100-year life, hopefully, would be long life, loose fit, and ideally we'd have designed that for adaptability and that sort of thing. So it's a sort of hugely difference in lifespans. And the other thing is that we want to make them independent. So actually, if we want to put a new facade on the building, that we should better peel that off, and it doesn't compromise the structure. If we want to maintain the building services or replace the building services, some of which have a 20-year life, we don't want to hide them behind finishes that might have, I don't know, a several thousand-year life if it's a ceramic tile, for example. So that's a very useful sort of baseline to have the building in layers principle. And then to pick up another one, I think design for adaptability was really interesting in looking at this when I was researching the book, and this just trying to capture some of the sort of principles that came out of the research, and the idea that lots of old buildings have survived for a long time. Victorian warehouses and Georgian townhouses are great examples. And some of the features are that tend to have quite generous floor to ceiling heights, really good use of light and space, and feel good to be in, and are buildings that we really like being in. Have generous cores and are quite often rectangular in design, because that's easier to both give you nice clear floor plates, but also makes it easier to build up or out on a rectangle plan form. And I think one thing we've been doing and promoting is this idea of scenario modeling. So you take your existing design and say, what could we convert this into? Are there options to turn an office into a hotel or into residential or whatever, and what are the implications of that? And I'm not suggesting that every building should be able to be turned into a lab, because that's clearly would be seriously over engineering. But are there options? Are there tweaks to the design that might enable it to be more adaptable in the future? And just there's a sort of scenario modeling diagram, and it's something we've been doing for Moorfields Eye Hospital, trying to build in some principles of circular economy, and looking at how that building. I mean, that building has to be. The brief has asked it to be very adaptable in that they've got both UCL research in that building as well as live hospital. So they're looking to see how they might be able to change out spaces in there and make it more adaptable, even to the point where we've got interstitial plant floors, for example, and being able to change the facade away from, if you want to take out that plant floor at some point, to be able to change that back into a facade that could be used for wards or for treatment space or whatever. And then in terms of design for disassembly, I mean, of course, you can be starting to think about disassembling the whole building, and that's the big challenge, I think. And at the moment, the buildings are really not designed around assembly in general. But this is just zooming down into the detail here. So an example of a building, a flooring system that is a dry lay floor tile, which is one of my favorites, and it's laid onto a rubberized grid that has, and then there's interlocking tiles on top of that create the whole flora, and this is being used. This is used in Heathrow Terminal 5, and it allows you to raise up the floor if you need to get underneath it. If you've got a raised floor, it means you've got a T-point in a building, you could move that somewhere else. It means if you crack a tile, a couple of months into the building life, then you can change it out without having to suffer it for the next 100 years or whatever. And what we found really interesting is that although I'm thinking, just imagine if the whole building or the whole interior anyway was designed in that way, that modular dry laid way. And what was interesting about the costing when we did a whole life cost analysis on it for UCL estates is that they do cost more per tile, but when you look at the time it takes, so it takes 2 days to lay this system, whereas it would normally take 2 weeks. So as a comparison, you're saving a huge amount on the program, and you're saving money in the process, because you can get straight back on and start doing your next fix. And then of course it saves money during its life, because you're then not having to smash that apart and dispose of that and buy new. Another cool one which is just out, you've probably seen last year, I think it was in Design actually, but it was the K-brick, which I think is really interesting. We've been looking at that for a couple of projects now, which is a unfired brick, so it's not fired, and it's made from waste, construction demolition waste, and has the same properties as a brick. And I think it's really interesting that it's doing quite a lot of the things that we'd want a circular product to do, and by not being fired, you're using a tenth of the energy and a tenth of the carbon emissions of a traditional fired brick. And then another one which I have been another example which I think is really catching on actually, and a lot of our clients are really interested in, is in terms of reclamation of materials. So this is raised floor tiles. Sorry, I got 2 floor examples, but raised floor tiles, 600 by 600. They're standard industry wide. There was thousands of them coming out of this building that was near my office actually, and I thought, oh great, maybe they're going to recycle these or reuse them in some way. But actually, they started to rust outside and started to buckle and stuff. And so we looked it up and found that there is one manufacturer called RMF who actually will take back, they'll come and get your raised floor tiles that you don't need anymore, and they remanufacture them and they clean them all up. They get rid of all that adhesive we've coated them with. They retest them, they re-warranty them, and that's absolutely critical for reuse. That problem is often that there is no you don't have that backup from the manufacturer that says yes, this product is fine to reuse, and they'll sell them back, and actually they're cheaper than the new ones, so they're 25% roughly cheaper than the new ones. So you think, crumbs, what isn't to like here? And actually a lot of our clients are agreeing and saying that they are actually going to do that and reuse them. And then I think the other one I think is really interesting is this idea around the way that we currently consume things. So the manufacturer makes something, we buy it, and then we're responsible for the whole of the rest of its life. So then we have to maintain it, upgrade it, and have pay for the disposal. And something like lighting, for example, the disposal costs of lighting, it's a special waste, so it has to be looked after. It doesn't just go down the standard waste streams. And lighting is another good example, in that actually it's something that is moving very quickly as a technology, and upgrading has huge benefits. So this idea was used by a few people. So Philips have offered this lighting as a service, so it's sort of Payperlux is the phrase, and Schiphol Airport do it. So they didn't pay anything up front, and then they pay a monthly or quarterly charge for the use of the lighting, and they can even do, and they have some models there around energy efficiency as well. So not only is it circular principle, but also you can say, if your energy use goes above a certain amount that you've pre-agreed, then your cost, you pay less rent for that quarter or that month, which I thought was really interesting idea. And I think lighting is a difficult one to see how that would work in lots of sort of particularly commercial buildings, but even residential buildings. But I think one that is really interesting and is growing is Mitsubishi do a lift pay per use model, and I think that's really interesting, because you would be contracted with a lift manufacturer anyway. So it's unlike lighting, whereas you might have your own maintenance team or whatever on site to deal with lights. So I think there's definitely some future there, and it's something that's happening in the Netherlands a lot already. So and I think the sort of more general sort of business models is another interesting one here that sort of captures lots of things, is remanufacturing. And remanufactured paint is something that's well up and running. Paint 360, take waste paint from construction sites, and there's so much of the stuff that they are turning it away, and it's all pretty high quality. You know, generally we all spec high quality paints, so they get a very high quality of waste paint. They can remanufacture it and turn it into any colors and any types of paint that you want. What I love as well is it's a social enterprise, and actually they are bringing people into work who probably wouldn't been employed otherwise. So all round a really good one. Deals with a waste stream that is currently problematic and is quite often incinerated, or people just dump the paint on top of the other waste, and it just gets mushed in with all the other stuff on the skip and things like that. So lots of advantages here, I think. And I think what's been interesting is the take up of the circular economy ideas. There's lots of clients we're working with who've built that into their briefs now, and are looking very seriously at the advantages here. And this is just one example from Clarion Housing for their Merton redevelopment project, which I think is a 4 or 5 year redevelopment project, and you know, they've picked out some really key savings and some things you wouldn't immediately think of. So as well as saving loads of money on waste disposal and requiring so much more require much less virgin materials, they're also saving on impacting the local community by not having quite so many lorries thundering past other houses full of waste and stuff. So I think, you know, really elegant solution really, and very applicable to sort of long-term regeneration projects. So lastly, I just want to pick up briefly on what's going on with the London plan. So I know this is London-centric, but you know, I think it's really leading at the moment. So the London plan has now been approved by the Secretary of State, which is fantastic news. So it is actually fully fledged now, and I was delighted when the GLA asked if they could use my diagram for my book in the London plan to demonstrate and show the hierarchy there that we've set out, that I set out in my book. And so the main thing is that now the GLA, or have been asking for about a year now, for all referable projects to the GLA, you have to write a circular economy statement, and then there's a whole load of requirements underneath that. And at stage 2, I think what's really crucial is and I know Dan spoke about, you know, table 1 and the strategic approach in the last ACAN session. This is about really moving towards planning applications. And I know it says formally that you don't do planning until stage 3, but I work on lots of projects that are pushing in a detailed application at stage 2. And basically what we're looking at is filling in a table that sets out your key commitments against these principles for the planning application and for that circular economy statement. So you can see the top there, A and B is really about, A is about lean design, thinking about responsible sourcing, reducing the amount of materials that we need in the first place by being clever about it, refurbishing even better. And then the second one is really about thinking about the life of that building, about longevity, adaptability and flexibility, and designing out the waste that might be arising from construction, demolition, excavation. Can we create less basement? Do we have to excavate as much as we are? Have we thought about how much waste might be arising during the operation? And can we reclaim stuff from any demolition that's going on? And then the last section is more just about managing that waste. So I thought it just worth mentioning as well, and I've just put a link in there. So we have been working with some brilliant people at the University of Sheffield on creating the Regenerate tool, which is really trying to help people at those early design stages to think about and challenge the design and think about what the circular economy opportunities are at those stages. And so there's a tool there which you can download and have a play with. It's still a downloadable spreadsheet, but we're working on a fully online tool that would allow you to go through the principles I've just talked about and pick out some interesting ideas, and you'll see that anyway soon. So yeah, please have a play. That's a copy of my book. That's what it looks like. So yeah, please buy 2 copies, give one to a friend, you know, great gift for somebody. And I just want to leave you with the thought that buildings should be or can be materials banks. So what we could be doing is putting resources into our buildings now and taking resources out of the existing buildings we've got. And then in the future, we could be withdrawing those resources. So future generations could be using those. And I think what's really coming out strongly at the moment, and research I'm doing for my second book, my second edition of the book, sorry, is that urban mining is becoming a very strong area and interest. And this idea that rather than digging stuff out of the ground in some other part of the world, we've got this huge resource that is our towns and our cities already. And actually what we could be doing is reclaiming bits out of that and then reusing those again. Thank you. That's me.
Thank you so much, David. That was really interesting. We ran a little bit over time, so we're quickly going to go over to Salma now.
Thank you, Tallinn, and everybody. Can you see my screen now?
Yes.
Yes. Brilliant. Hello, everybody. It's a pleasure to be here today. My name is Salma Zavari. And first of all, I would like to say thank you to ACAN. You're doing a brilliant job. I followed ACAN's stage 1 with Dan and Nick, and today with Dave. It's brilliant. I would like in my presentation to build up on what had been said before and provide with 3 projects, 1 main project, Whole 7, and 2 sister projects, which they share concepts, but they are very different in actuality. But before that, a little bit about who we are and what we do. Our practice, Vandkunsten, is established 50 years ago. We are a front runner in Denmark in urban planning, affordable housing, co-living, and sustainable and resource-friendly architecture. If I want to describe, we are very pragmatic architects. For example, we have LCA and LCC experts in-house that they develop tools, and we use those tools to develop our and use them in our design concept. And they're usually open source, so everybody can use it. The first project is a competition we did in 2011 for Adaptable Future, and we won. We were one of the winners with the proposal, the Industrial Favela. It was about how architecture can foresee, embrace, and adapt to the possible change. So both the plan and facades were adaptable. I'm not going to show you the project itself, but one of the principles that it was on, it was about, we have these 2 different schools of architecture. Industrial production that we architects, we know well about. It's a top-down structure. It's a vehicle to deliver building practice, and it is based on easy assembly technology, precision, affordability, scalability. In contrast, we have the notion of favela, and regardless of the social status of the buildings or the users, the vernacular architecture, which is the bottom-up structure, it functions based on local democracy, user control, individual actors, and do-it-yourself operators. So this project was a hybrid system of these 2 schools, and then taking advantage of both of these. How? The backbone of this project was this diagram. And thanks to Dan and David, we learn a lot. I'm not going to like the left side of the line, it is, we went through it. I'm not going to focus on it. It's about design for disassembly, layering, flexibility, multifunctionality, reuse, recycle. We learned all these tools. I would like to focus on the right side of the diagram, which is the social sustainability, how it frames itself in the cultural context of the project to deliver the lovability quality. And how we do it is that we as a designer, when we use all of these other tools, we put on the glasses and say, okay, design for this system, how does it work with the identity of the project? How the combination of materials works with tectonic articulation and sensuality. If you look closely to the diagram, you can find Vitruvius triangle. We shouldn't forget the beauty leg and to secure the durability strategy. In 2014, we did this project for Nordic Build component reuse, which we did 25 prototypes out of discarded building components, which shows a parallel to all the environmental and economical advantage. It aesthetically can enhance architectural quality. We would like to add re-beauty to the triangle of reduce, reuse, and recycle. We believe that with no beauty, we have no sustainability. We shouldn't forget that. These prototypes were used, was exhibited in a Danish pavilion in Venice Biennale 2018. For example, this is origami folded metal plates. These are flattened ventilation channels, and we adore this sort of aesthetics. And reused roof tiles and reused windows. And we dived very deep into all of these 25. So it's a publication that you can download from our website. And all of these designs are open source, so everybody can adapt that in their project, and all the business plans. It's researched very deeply. So if you like, you can take a look. Another tool that we use in our design phase, and we recently were part of to make it, it's this construction pyramid. Like design phase is a phase that we don't take final decisions, but it's many of the main decisions are taken, and we shouldn't take wrong decisions. This material pyramid is one tool that it helps the architects and designers in the design phase, but it's very easy to communicate. It is not very user-friendly to show LCA and LCC calculation in the design in early phase to clients, but this is, or users. This is based on food pyramid that we all know. And for example, at the top are the high carb sugar material food that you should minimize, and it's exactly the same. And in the bottom is the more healthy. How can we have healthy buildings? And it's a good tool to communicate. And now my darling project, Hall 7, we did that in 2016. It's located in Roskilde, in Musikan. Roskilde is around 40 minutes train from Copenhagen, and Musikan is a district which municipality has a very progressive agenda for. It's going to be a new district centered with a creative and cultural association and institution, and this is Hall 7. This is Hall 7 to the left, and we have such a glam neighbor. It is a museum of rock music, and the municipality gave access to this hall for only 10 years. So the project was is temporary. The brief of the project was that this is going to be a workshop for two main groups. Group one are B-steaded, that they gather around different activities. It could be music or crafting or food indoor and outdoor. And the group two is a group of creative people who have different creative projects, usually around Roskilde Festival. Roskilde Festival is the second largest music festival in Europe. I think after Glastonbury is the largest. And makers had already some containers that they were using it as a storage, and it was in one other hole. Excuse me. And we thought, to minimize the waste, why we don't give them more retired containers, so when this 10 years is over, they move out with these new containers, with these new facilities. And so we had a group of workshops with them, and we placed this is the organization of the groups in the hall, and the makers group was located at this end, and where they have the workshop and where the action is happening. And this was the group for the club group, and they have an orangerie at the end. And in this corner, we placed the kitchen and the washroom as an excuse that these two groups interact with each other. This is the noise diagram, and this is where the action happens. They have wood workshop and metal workshop, and here is the peace and silence. This is the climate zone diagrams. Because this the project was temporary, it was not an option to insulate the whole hall for just 10 years. So we came with the idea that defining different climate zones. The gray is the open hall, in winter is as cold as outside. The yellow is the middle climate zone, in winter is around 17 degrees, and one can sit comfortably with a pullover. And the blue is comfortable climate zone, fully ventilated. This was one of the first spatial planning that we came up with. And the plan was that it used to be a bridge here so people can go on top, and we thought we can have the bridge on. But what we did in the design phase, we solved fire and we solved accessibility. Because when we apply circular economy in the project, we need a bit of flexibility later on in the next phases. So as soon as we had the main concept, we solved these two issues, accessibility and fire. And to come to this concept, we had very close workshops inside and also in our studio with both of these groups to hear what they want and how can we deliver the best. So this is the plan that we gave them, activity plan in the beginning. And this is as built plan. As you can see, there are some revisions, but we don't have any major change in later on in the phase. So it was useful to do that. This was the floor of the hall, and because it used to be a factory, it was pretty damaged. Easy solution could have been that we just cast concrete on top and level it. But when it comes to concrete, we are very cautious. Concrete is always a loser if we calculate CO2. So we went many visits to the hall, and we mapped and traced all of these cracks, and we sort of mended all these cracks with the minimum amount of concrete. It's sort of, also you have the history of the hall. We call it kintsugi floor, like a mending Japanese technique to mend broken china. This was the facade before. We wanted to clean it up, but keep the different tectonics later on to have this dynamic facade. This was a diagram we drew in the beginning, and it shows how it's fully designed for disassembly. And many of our detailed drawings in tender phase was based on this drawing. So this is, for example, laser workshop. In 10 years, they have to just loosen all the fittings on the door and installation, and then the container is ready to find its new place. And when the lifetime of the container is over, they have to open this cork fitting, which is also an architectural motif around. And with a suction machine, they have to remove all this hemp insulation. We use hemp insulation because you can reuse it 100%, and then they can unscrew the rest. This was the floor of the terracing part of the hall, and it has a very interesting texture. It used to be a sport hall floor. But what it was cool about that the users came and helped us in cleaning the floors. And they got involved in the process. And I followed them on social media, and I can see that they add to the project and they own the project. So that increased the lovability quality when they feel that they own it. This is the shield between two climate zones with all these recycled windows. And this aesthetics we adore. The heat source for the climate zone in the middle is this rocket oven. It's a wood burning oven that the chimney goes horizontally first, so people can sit on it and make the best out of the heat. And they were also involved in building that. And it is L-shaped, so the social aspect of it is they can have a Hugli time. Like I think you know what's Hugge, thanks to Sandy Tugsvik. This is the workshop where all the creative people and they have different wood workshop and metal workshops. This is the facade for Orangerie with all the reused windows, and we like to keep it intact, the rest of it. This is the facade to the south side. And many of the decisions were taken on the site. For example, when they took out all this concrete to put the window, they reused it to make the stairs. They reused it to make bike racks. And this is the orangerie at the back. And you can see all this kintsugi flow and reuse the windows and how homey they made this orangerie. What is important about this project is that despite of its incredible humbleness, it encapsulates perfectly many of circular economy principles that we aimed for: design for disassembly, flexibility, reuse, reduce, users' involvement, lovability. I believe we architects, we designers, we should challenge ourselves. We should use all this knowledge of circular economy that we have, and also we should use our creativity, our design skill to make the best value out of material. Like, everything is precious, and we shouldn't find beauty in them. And because with no beauty, we have no sustainability. Thank you.
Thank you so much, Salma. That was great. We've had so many very good questions come through. So just before we start asking the questions, we're going to do the poll now because we missed it in between. Okay, so if you wouldn't mind just putting in your information. So I guess if we've got David on the line too, let me just start off with a question to David that we had. This one is from Sagar Shah. We've had an interesting question come through regarding the extraction of materials being less bad than others, as well as ethical concerns affecting human rights in how these are mined. So his question is, their question is, why is mining bauxite considered bad when PVs/wind turbines also rely on bauxite amongst other resources like coal and lithium? And PVs/wind turbines are recommended under the donut model. What about the circular economy for minerals that are vital for solar panels and turbines, which are mined in huge amounts? Sorry, that was a long question, so let me know if you...
Yeah, no, that's fine. Yeah, no, I absolutely agree. I think, you know, we the whole idea, that was just one example, you know, that I think we're mining loads of stuff, aren't we? And the rare earth metals issue is a huge one, and lots of illegal mining and you know, child labor and stuff going on. It's you know, it is terrible, but I mean, it's in everything, isn't it? I mean, it's you know, we could argue that about our mobile phones are full of, you know, some pretty nasty materials. I think that, you know, the premise is that on the technical cycle is that actually what we do is we try and reclaim those bits back out and go back to manufacturer, rather than at the moment where we've got that, you know, linear approach where something comes in one end, we have to keep feeding raw materials in one end and out comes a whole load of waste out the other. That's the premise. So it doesn't matter what it is, that we have extracted, you know, huge amounts of copper, and that copper, that most of what we've extracted is still in use. So there is a sort of quite a clever situation where some materials are working really well, so and copper and to some extent aluminium is true, whereas others are actually on a continuous sort of downward trend. You know, thermoplastics, for example, that you know, once you've created a thermoplastic, there's not a lot you can do with it. You can grind it down and use it to make Sainsbury's car parking signs, you know, as a sort of granule that you squish together with another resin, but there's not much else you can do. So I think it's really just thinking, as I say, it's all about what's the, you know, the slightly sort of philosophical approach about what's next for that material, for that building, for that resource, for that product, you know, so that we're thinking about prolonging the life of it and keeping it in play forever. And that applies to, you know, anything from photovoltaic cells to whatever else.
Yeah, I think that might even tie into the new version of your book about urban mining as well. I know that's a very popular topic amongst documentaries on urban mining. Mm. Okay, so maybe to follow up on that question regarding resources, we have a question from Monica. How do you deal with issues related to fire safety regulations that require applying often toxic products onto natural materials that could otherwise be safely reused or disposed? And then also following up on that question as well from Monica, out of experience, do you think that other natural materials, not only wooden fabrics like natural insulation, stone, natural plasters, etc., could be considered part of the biological cycle? I don't know if I should put that to David or Salma.
Yeah. I mean, I can give an example. I think, and sorry, Salma, I'm sure you've got lots of ideas as well. But one great one I've just been looking at is mycelium insulation, which you basically grow, and it's basically the sort of the roots and the stuff underground associated with fungi. And actually, what's amazing about it is it not only is so this is Biome that have been doing this brilliant organisation. They've been it's actually got better insulation qualities than a lot of stuff on the market. It's entirely compostable, so you can return it to the biosphere. Amazingly, it's naturally fire retardant, and there's actually a video of them actually trying to set it on fire with a blowtorch, and it just chars. It doesn't actually. So actually, we just there's a natural based product there that actually is hopefully addressing all of those questions. I mean, I'm not saying that everything is like that, but imagine if we could start to create more of those sorts of products, let down a more biological pathway to create products that can do more or better than we're doing currently.
I would also add to that, I'm a huge proponent of hempcrete, so that's a good wall infill and insulation material. Salma, did you also have something to add to that question?
For example, I have when it comes to containers, they usually, to earn centimeters, they use a foam insulation, and like wood or hemp is one of the they don't use it. And for our project, it was no go. We are not going to use foam because it's terrible for environment and you cannot disassemble it later. So yeah, that was one of the criteria we went with the hemp insulation.
Great. Okay, so another question from Casper. How does one design for adaptability and flexibility without over-specifying? I think that question came up during David's talk, but I'm sure that you also have a good response on that, Salma.
Me or Salma? Okay, I'll go. Yeah, so this question comes up a lot, and I think I can see, and people like to see that there's lots of tensions in this, which of course there are, and there's lots of potential conflicts. But I think my stock answer to start with is, well, one thing that designers are brilliant at is actually finding the way through all of those conflicts and coming up with a resolution that addresses that. And I think for example, around adaptability, it doesn't, as I said before, it doesn't mean that actually we're expecting every building to be turned into a lab and having huge chunks of concrete, to avoid vibration. What I'm saying is that we can add some adaptability into buildings, even at the small scale, in terms of actually making the interiors more adaptable, as well as the whole building. But if we're for example, we looked at a project which was some student accommodation, and it was all really about escape distances, and actually found that if you just tweaked some of the cores, the location of those cores at RIBA Stage 2, that sort of stage, then actually you could make it more adaptable for to be a hotel or to be residential accommodation and other things as well, which it didn't quite meet under its first sketch. And I think there's some ideas around there where actually you can see where the limits are, and what the issues are. You can actually start to tweak things, but it is a multidisciplinary study, and it doesn't necessarily mean you have to stick in loads of extra foundations and load of extra concrete to make it do that.
Yeah, those are really good points. I guess bringing that over to Salma as well, you discussed maintaining a fairly loose final design until actual construction of the building, especially in Hall 7. So what does that mean for the concept design stage, and how far do you go in the design if you know that iterative design is part of the process?
Yeah, we had the plan to have as much as reuse in the beginning. So what we did, we came with some main principles of the design, and we fixed that. And those principles, for example, I had more diagrams, what container we wanted to do, interior installation, which one out exterior, or so on. But during the tender phase, we were so flexible with the process. And for Hall 7, what was very good, we were sort of a dream team. contractor, the engineers, the users, the client, everybody were in fully alliance. And for example, I was on the next project, and in the morning I was in the tender phase. I was getting some pictures. Oh, we found these windows. What can, and the carpenter is waiting. Can you make a construction drawing and send it? So we had to see those sort of unexpected change which is coming afterwards, and leave those flexibilities. But we have to also set some principles that these are going to be the spine and the backbone of the project, and stick to them. Otherwise, it will be chaos at the end, and it's not manageable. And also solve the issues that we can in the beginning, like fire accessibility, and yeah.
And I know we're running out of time, but just a quick follow-up on that. We have a question from Philippa. How did you source reclaimed materials in the windows in particular for the Hall 7 project? And what came first, the design or sourcing of materials? I think you might have already just answered that a little bit.
Yeah, so I understand that was a special project because the client was municipality. So they had a good knowledge of what's going on in the area. So they were, oh, there's a sport hall being demolished, we can get that. And some of the windows came from the houses of the team. Like we need a bank, like it's not a scalable. We need a material bank for the city. We should plan, okay, the metabolism in the city should be controlled, so we can scale it up. And we can plan for, okay, in 2 years, that building going to be demolished. What are we going to do with the windows? And that is more effective way to do. But Hall 7 was a lucky project. It was the scale and the team were, yeah, that happened in that team.
Yeah, I love that project. It's one of my favorites. Unfortunately, we've run out of time, so I'm just going to share our closing remarks with you. Can you see my screen? Oh, no, not yet. Okay. So apologies to those that asked a question and we didn't get around to. We're very keen to capture the wealth of thoughts, ideas, and questions that have come up in this session. So we'll be adding your questions to the Miro board. Please do follow the link in the chat and continue the discussion. I know that our speakers might have some moments to log in and answer those directly after this discussion. And I'd like to quickly let you know about a few other ACAN events coming up. Firstly, we'd like to invite you to participate in 2 ongoing ACAN campaigns. Firstly, the Embodied Carbon campaign, which is calling for the urgent introduction of legislation to regulate embodied carbon emissions in the UK. And secondly, as well as the VAT campaign, which aims to push the Parliament to create a tax incentive to favor retrofit instead of demolition and new build. And we'll post the links to both campaigns in the chat, and we'll send out a follow-up email. Then we have our Circular Economy series looking at RIBA Stage 3 coming up in 2 weeks, lunchtime on February 25th. And then thirdly, if you enjoyed this event, we would love to have you get involved. You don't need to be an expert to join, and we'll be hosting a Circular Economy group social event on March 3rd at 6:30 p.m. So please join us for a wine and a chat. An Eventbrite link will be posted in the chat box here. And finally, a huge thank you to David and Salma, the ACAN team behind the scenes, and all attendees. Thanks for joining, and I hope you all have a great afternoon.